Okay, in this video I'm going to show you how to use a yield curve to predict recession. So the yield curve is a forward economic indicator that a lot of people use to see whether a recession is likely to happen within the next 18 months or not. So what is a yield curve? I have a graph over here. So when things are normal, interest rates in the future are supposed to be higher than interest rates in the present. So the longer term interest rates will be higher. But from time to time, this relationship changes. And that's usually an indicator to investors or to people that things are going to happen in the future. And this yield curve inversion is usually associated with a recession. Now, the yield curve that is most commonly used is the difference between the 10-year and the 2-year. I can see a graph here for the Federal Reserve. They actually have this as a data set. It's the difference between the 10-year and the 2-year. And that yield sometimes becomes negative. And the idea of the yield curve being able to predict recessions is because when it turns negative within the next 18 months, there's a recession. We can see here this gray area means that there was a recession call. And we can see how before that happens, the yield curve turns negative for these two specific dates, and it has led to a recession. So that's what I'm going to try to do here. So the first thing to do is to load this package. I really like this package Pacman because it checks that a package is installed in R, and if it is not installed, it installs it and then loads it. Now this usually takes a while to load up. It depends on your machine, and it might take up to 5 minutes. So I'm going to let it run first. This is the first thing that you want to do. And once it's run, we'll go through loading the data. Okay, now that the packages have been downloaded and installed, we can see where they are. So I'm using the usual tidyverse. I'm using lubridate to manipulate dates. I'm using timeTK to construct averages for time series. QuantMod is the package that downloads datasets from the Federal Reserve. QPCR allows me to create rolling windows for future values of the yield curve and recessions. And then I have here these two very common machine learning algorithms. I have the C50 and the random forest. Now, if you think that this takes too long to download, you can always download this notebook and create your own on RStudio and just run it locally. It might be faster. Now, once the data is downloaded, I went through getting recession data. This is the QuantMod package, and you have to put the source, which is FRED, Federal Reserve Economic Database, and this is US recessions. I believe this is monthly data, so when a recession was called within that month, it takes the value of 1, otherwise it takes the value of 0, so I'm going to run it. So I have it here for 2020, so a recession was called in February, March, and April, and that's why it takes the value of 1. And then I also downloaded the yield curve data. This is daily data, and so it's going to get the difference between the 10-year and the 2-year. Same thing, I'm using QuantMod, and here's where I'm also creating this indicator variable because this is just numbers. So it is like here. This is just numbers. So it's the difference between the yields. But what I want to do is I want a value of 1 for a month where a yield curve inversion happened and a value of 0 for a month when a yield curve inversion didn't happen. And so that's what I have here. So I have this variable indicator inversion that pretty much says if it was negative, give me a value 1, otherwise give me a value 0. And then I'm summarizing through the month. If at any point there was an inversion, then I want the whole month to take the value 1. That's why I'm using this max here. And I'm just printing the last points to see. And so we see here that 2019, before the recession of 2020, the yield curve inverted twice. So once in August and once in September. And so you can see here on the graph that it is very small here, but you can see that the number was approaching zero. And this was before the recession of 2020 was called for. So, we don't know if it was actually triggered by policy intervention or if it was actually what was going to happen just because of the business cycle at the time. But an inversion did occur, and that's what I have captured here. And I'm going to try to replicate this graph here a la Fred. And I created this ggplot. And so I have yield inversions. They take the value 1 if there's a yield inversion for that month. And I also have these gray areas here that represent recession. So I got this from like 1978, right? So here's where people think that there's some information about the future of the US economy based on the yield curve. And we can see here the small time-wise recession of 2020, and it was preceded by an inversion in the yield curve. Now over here, I'm just tidying up the data. I'm creating some new variables, month, year, so that I can tie it up later. For some of these functions, I have to use their actual package. There was some kind of conflict with either the Google Colab or with some of the other packages that are running. And so to fix that, I was just have to be a little more specific about what package some of these functions were coming from. Here I'm just getting a month and a year for my recession dataset. I do the same thing for the yield curve. And so now I have here my dates. I have the actual yield for the month. This is the average. I have whether there was an inversion at any point in that month or not, and month and year. So I can now join them. And you can see here how I'm using the package time decay. This is what you do when you want to calculate summary statistics for a specific month. There are other ways to do this using the tidyverse, but I find this one easier. The only downside that I see is that you can only manipulate one time series at a time. Then I'm going to join the data. And so now I have my data set of the yield curve for that month, the inversion for that month, and whether there was a recession on that month or not. And of course, our goal is to predict a recession in the future, not predict a recession right now. So here's where I'm using that other package, qPCR, and I'm using this function rollmax. And this one is going to look into the future. I can create a specific window. So I have a 6-month window, I have a 12-month window, and I have a 18-month window, which is the preferred metric for is the preferred time frame for calculating the likelihood of recession using the yield curve. And once you run this, what it does is that it goes 1, 2, 3, 4, 5, 6 months into the future. It's going to figure out whether a recession was called 6 months into the future, and it's going to give me a value of 1 if it did, and a value of 0 otherwise. And same thing for a year, and same thing for a year and a half. Now I'm going to join this windows to my actual data set that includes the yield curve and the recessions to create a master data set. So let's look at this. So notice, August 2018, 18 months from August 2018, there will be a recession. There will be the 2020 recession. This is going to be important because when I train the models, I don't want to know that a recession had already happened, right? We don't know this in the future. So in August of 2018, I don't know that a recession is about to happen 18 months from now. So when I'm training the models, I need to choose a date that does not include any information about future recessions in the training model, because I want to use that in the test model. So that's why I'm going to choose this August of 2018 as the last date for the training model. and then let the model test the future and see if it's able to predict the recession in 18 months. So based on that, based on August 2018, I'm going to create my training and testing data sets, right? Because I want it to be right here. I don't want the indicator of a recession 18 months from today to bias any results. I want to get here not knowing that a recession happened 18 months. I want to get here not knowing that this inversion was going to happen. I create my train and my test data sets. I'm pretty sure there's a cleaner, more elegant way to do this, but this is how I did it. So again, I went back to August of 2018, the last time that an inversion occurred, before the last time an inversion occurred, and before any information that we had about a future recession, and see how the model can actually predict that. And then I'm going to fit both models. So I have the C50 algorithm, and I have the random forest algorithm. These models run very fast because we don't have that much data. And then I'm going to calculate probabilities. And this is what I get. So this is the recession of 2020. And this is the model predicting the likelihood of recession using just this data since August of 2018. And notice here both algorithms predict a recession happening within the next 18 months, about April. No, it's not April. By, yeah, by April of 2020. Now, if I let this run all the way to the end of 2022, this is what we're hearing in the news lately, that there's an imminent recession coming up. And it's because both algorithms have been flashing red in the likelihoods about a recession coming within the next 18 months based on these models. So what are the actual probabilities right now? So of course, I'm going to cut this at the end of 2022. So even if you're looking at this notebook in 2023, it would not use the current information for 2023. It's just going to stop at December of 2022. Because what I want to know is I want to see if a recession within the next 18 months actually happens after this flashing warning signs from the yield curve. And so the actual probabilities right now, as of December 1st of 2022. I have the random forest algorithm giving me a 100% chance of a recession within the next 18 months. And I have the other algorithm giving me an 87% chance of a recession within the next 18 months. So I think we can say that it is more likely than not that the US is going to have a recession within the next 18 months based solely on the yield curve. There you have it.